Hi, welcome to Biomaterials. This is BMEN 4020, Section 202. Our topic was Fourier transform infrared spectroscopy. My name is Abhishek.
I'm Harris Kum.
My name is Andres.
All right, so let's talk about a technique that is used for this instrument. FTIR uses Fourier transform technique to mathematically calculate infrared absorption, emission, and photoconductivity of solids, liquids, and gases. How the instrument works is that a light source containing frequencies of various wavelengths is pointed towards a glass which then reflects the light onto a beam splitter. The beam splitter then splits the beam into various directions, causing them to go towards the movable mirrors and fixed mirrors. The beam is then reflected again back towards a point where they all meet, and the beam is then hit onto the sample. After hitting the sample, the beam causes a state of excitement at a molecular level. There, as you can see in the image on the right bottom, there are 6 ways the molecules can vibrate. Some of the advantages of the spectrometer is the time taken to determine the composition is very minimal, and the mechanics of the instrument itself is very simple with only one continuously moving part, the movable mirror. Some of the disadvantages of the instrument are it is unable to detect identical bonded molecules like H2 or O2, and also not being able to accurately measure the liquid samples due to water being involved in aqueous solutions. Aqueous solutions require additional attention because aqueous solutions have water, which is a strong infrared light absorber. Some of the other techniques involved with the FTIR are attenuated total reflection, specular reflectance, reflection absorption, and transmission. And each of these techniques are used for different materials, for different rigid and surfaces. Attenuated total reflection is used to analyze a variety of solids and liquids, and it requires very minimal sample preparations. Specular reflectance, on the other hand, is used for samples that have glossy surfaces, such as glass or crystal surfaces. The other technique is the reflection absorption. It is suitable for thin polymer films, residues, and paint. And it is performed on a thin film on reflective surface. Transmission, on the other hand, is an infrared beam aimed at the sample and is used to measure the extent of absorption. It's suitable for most gases, liquids, and solids. The instrument itself has a few components that can be categorized. Like, one is the sample compartment, and the other is a compression tip. The compression tip is used to hold the sample in one place so that the beam can easily hit the sample. And on more of the newer instruments, there's also a touch panel included so that the users can switch between various FTIR techniques.
The amount of light absorbed or transmitted by the material that's being analyzed. On the figure on the right, the y-axis represents the amount of infrared light that's absorbed or transmitted by the material, and the x-axis represents the infrared spectrum. The resulting spectrum is plotted between 4,000 inverse centimeters to 400 inverse centimeters. The resulting plot is unique per chemical structure, so this creates a molecular fingerprint that is used to identify chemical structures.
Use organic and inorganic materials. For this class, it's polymers to be specific. And this technique is used to determine the structure and the composition of the polymers. Organic samples need to be prepared in the lab, so we have various separation techniques to separate the organic samples from the impurities. This makes the result clearer when using the FTIR technique. Also, like solids need to be crushed because you only need a small sample of it to place on the machine. And films also need to be prepared into like the thin film to be placed on the machine that takes films. The resolution can range from 2 inverse centimeters to 16 inverse centimeters, and this also depends on what type of instrument is being specifically used. So, for example, the ATR, FTIR gives you properties up to 5 microns within the sample, while high spatial resolution can go up to 20 nanomicrons within the sample. So, what instrument you use, what resolution you need, also determines how well the properties would be and how many of those properties you can get. These are a list of our references. We use the textbook, of course, and a few other websites and articles.